From left, M1 Chief Operating Officer Patrick Scodeller, M1 Chief Technical Officer Denis, second NTU ATMRI Director Professor Duong, and NTU Professor Huat, with the custom drone built by NTU which can be controlled through M1's 4.5G mobile network. Credit NTU Singapore Researchers from Nanyang Technological University, Singapore. NTU Singapore has embarked on a research project which uses existing high-speed mobile phone networks to track and control drones. In collaboration with a leading telecommunications company, M1 Limited, researchers from NTU Singapore will be mapping the signal strength of M1's 4.5G Heterogeneous Network HetNet. Knowing the exact cellular signal strengths of Singapore's airspace will allow air traffic planners to know which routes are safe to fly for unmanned aircrafts and which routes are to be avoided due to poor signal coverage. A memorandum of understanding for the research project was signed today between M1 and the Air Traffic Management Research Institute (ATMRI), a joint research centre between NTU Singapore and the Civil Aviation Authority of Singapore (CAAS). This partnership builds on the successful trials which both parties conducted in 3 different locations in Singapore, using M1's 4.5G HetNet to provide command, control and communication capabilities required for safe and efficient drone operations. Current airspace regulations in Singapore state that all unmanned aircraft systems (UAS), commonly known as drones, have to be flown within linear sight of their operator. NTU's custom-built drone can be controlled and tracked in real time through M1's 4.5G mobile network. Credit NTU Singapore. Conventional drone operations use an unlicensed spectrum such as 2.4 GHz band to provide short-range linear-side wireless connectivity, but it is susceptible to radio signal interference. In contrast, a well-optimized 4.5G HetNet provides secure, low-latency and high-throughput mobile connectivity, enabling drones to fly beyond visual range in an urban environment. In addition, drones could send real-time data and telemetry feeds during flight, with the precise aerial locations monitored over M1's 4.5G HetNet. This paves the way for a dynamic and robust unmanned aircraft traffic management solution required for the smart utilization of Singapore's urban airspace and its surrounding sea-to-shore coverage. NTU Singapore Professor Duong, Director of the ATMRI, said command and control of UAS is a topic of critical importance, especially when commercial usage of drones is taking off for logistics, surveillance and recreational use. NTU Singapore is at the forefront in both autonomous vehicles as well as air traffic management research. We are working now to establish an air traffic system which can effectively control and regulate UAS traffic in a congested airspace. By working with key industry partners like M1, we aim to translate our knowledge into practical applications beneficial to Singapore and other megacities, Professor Duong said. Mr. Denis, Chief Technical Officer of M1, said, "This collaboration is another innovation to accelerate Singapore's transformation towards a smart nation." Interest in drones has already taken off beyond recreational and hobbyist groups, into serious commercial applications. Mobile technology has the potential to expand and extend the capabilities of drones to enable incredible new applications such as using drones to perform search-rescue operation at remote or inaccessible sites, aerial infrastructure surveillance, delivery of parcels quickly and efficiently, and even new entertainment channels such as first-person view drone race. NTU's drone being flown in front of my world building using M1's 4.5G mobile network, which has low latency and is more reliable than the conventional 2.4 GHz wireless band. Credit NTU Singapore Research Outcomes. Leading this joint research project will be Professor Huat, an expert in robotics and UAS from NTU's School of Mechanical and Aerospace Engineering, and ATMRI Senior Research Fellow Mohammed Faisal bin Mohammed Saleh. Together with engineers from M1, the project will map out the signal strengths of M1's 4.5G HetNet performance at altitudes up to 130 meters (400 feet), or about the height of a 36-story building, using UAVs. This will help researchers to identify potentially usable airspace for drones which have sufficient signal strengths to enable proper command and control. The researchers will also test piloted and autonomous drone operations beyond linear sight using 4.5G HetNet, which could pave the way for a similar use in the future 5G networks. The joint research project findings will contribute to NTU Singapore's development of traffic management solutions for unmanned aircraft systems, an objective that was announced in December 2016 by NTU. One of the key enabling technologies required for such an air traffic management solution is a command and control C2 link for unmanned aircraft, which is critical to ensure operational efficiency and safety of drones, especially in a dense urban environment like Singapore. The joint project is expected to last 3 years, with M1 providing usage of the network and their engineering expertise, while NTU provides the expertise in traffic management of unmanned aircraft systems. Explore further traffic management solutions for drones in Singapore's airspace provided by Nanyang Technological University.